Welcome to our comprehensive exploration of blockchain versus traditional databases. In this video, we'll delve deep into the fundamental differences between these two technologies, shedding light on their respective strengths and weaknesses. Traditional databases. Let's start by examining traditional databases. These databases rely on a centralized architecture, typically involving a single server and client-server communication. Data control and management are concentrated within a central authority, making traditional databases susceptible to security breaches and data manipulation. While they've been the cornerstone of data storage and retrieval for decades, the limitations of this model are becoming increasingly evident. Blockchain databases. In stark contrast, blockchain databases operate on a decentralized framework. Instead of a single central authority, multiple nodes participate in the administration and validation of data transactions. This decentralization and consensus mechanism results in robust security. Any attempt to tamper with data becomes exceedingly challenging, as it would require altering records across multiple nodes simultaneously. Integrity and transparency. One of blockchain's most celebrated attributes is its unwavering commitment to data integrity and transparency. Every transaction is recorded as a block in a continuous chain, and each new block includes a reference to the previous one. This structure ensures the immutability of past transactions and allows users to trust the integrity of the data. Transparency is another hallmark, as users can trace data changes over time, enhancing accountability. CRUD versus read and write. When it comes to database operations, traditional databases support create, read, update, and delete operations. In contrast, blockchain databases are primarily append only, meaning they support write and read operations. Once data is added to the blockchain, it cannot be altered or deleted, making it ideal for applications that require a secure and tamper-proof ledger. Validating and writing. Blockchain's unique feature is the ability to validate and write transactions simultaneously across the network. This process ensures data consistency while creating an immutable ledger. Each validated transaction becomes a part of the blockchain's history, contributing to its transparency and security. Decentralized control. The decentralized control inherent in blockchain significantly mitigates the risks associated with centralized databases. In traditional databases, a single point of control can lead to data manipulation, unauthorized access, and security vulnerabilities. With blockchain, no single entity has ultimate authority, enhancing data security and reducing the potential for manipulation. Scalability. While blockchain offers numerous advantages, scalability remains a challenge. The process of validating transactions across a distributed network can be slower compared to centralized databases. However, solutions like sharding, which involve breaking data into smaller, more manageable chunks, are being explored to address scalability issues and ensure faster processing. Conclusion. To sum it up, blockchain databases offer enhanced security, transparency, and data integrity through their decentralized and immutable nature. However, scalability hurdles need to be overcome for blockchain to achieve widespread adoption across various industries. Head to ultahost.com to get started. Thank you so much for watching, and if you find this video helpful, please don't forget to like, subscribe, and hit the notification bell for more tutorials and helpful content like this.